Yeah, good. So then to do part B, you do the opposite. So you go, we want 10 square inches. So and we want to figure out the angle, right?
Yeah.
So we have to go the angle divided by 360 times what? We're done with A. Is that what? For part A? Mm-hmm. Is that why I is what? Yeah. Okay. Hey. What are you going to do for you? We are trying to find the angle, okay? So we know, what do we know? That the original area was 430 square inches, and now we want that area to be 100 and, oh, just 10, huh? Okay. So how do you solve that for the missing angle? Divide by 430 and multiply by 360. If I go 10, yeah, divided by 430, and then times that by 360. I don't know why you would want a windshield wiper to scrape out such a tiny little 10 square inch area, but if you did, you need your angle to be about 8.4 degrees. Still agrees. 8.4. Okay? Alright, then we jump to 5. Oh, there's more. Oh, fun. Suppose bug A lands on the end of the blade farthest from the pivot. Assume the wiper turns to an angle of 110 degrees in one cycle back and forth. So it's going across and back. That's one cycle. How far has the bug traveled? So I do what? No, because we want to know just the distance that it's traveling. Okay? So who was telling you the arc length formula for the Okay, so that's what we want to use now. We want to figure out what's the length of that arc. And then double it because it's going one way and then back. So our arc length formula is F equals R times theta. Bless you. Good insight. The problem is that the angle needs to be in radians to use this formula. Right now it's in degrees. Okay, so I need to take 110 degrees and change it into radians by multiplying by pi over 180. So should we go ahead and just figure that out in the decimal? Okay, so 110 times pi divided by 180. So that is about 1.92 radians. Okay, so the distance that bug will travel will be equal to the radius of the wiper blade, which is 22 times the angle in radians, which comes out to be about 42.24. But that's only one trip, right? Right? Yeah. So now they're going to go back because it says one complete cycle, so we need to take that times 2, which will be 84.48. Okay? Alright, D. Suppose bug B lands on the end of the wiper blade closest to the pivot. So assume the wiper blade turns through an angle of 110 degrees in one cycle of the wiper blade. How far has the bug traveled? So it's the same thing except now the radius is what? 6. So we go 6 times 1.92 and then double that. Huh? 5S? Cell phone is the latest cell phone. 5S? When I make S's with my left hand, they look like 5. But when I make S's with my right hand, they look like 7. I know. You know what it stands for? It stands for arc length. Yeah, no wonder you're confused. Yeah, I don't know why that's what it's
Not there yet.
because if we did that, Sydney, then when you see it in your book, you'd be confused. I have to prepare you for the outside world. I don't get to teach you math the way I want you to teach you math. I have to prepare you for it, and everybody else does. Anyway, so I'm going to go 6 times 1.92. That's 92. That gives me the arc length, and then I need to double that because the bug is going all the way around. So 23.04. Yay, bug. B. Suppose bug C lands on an intermediate location of the wiper blade. Assume the wiper blade turns to an angle of 110 degrees. If bug C travels 28 inches after one cycle of the wiper blade, determine the location of bug C. So again, we're going backwards. So if they're going 28 inches back and forth, how many do they go in each one? 14. So we want to find an arc length that's equal to 14 when we know that the angle is 1.92 radians. And that will tell us how far away from the pivot point the bug is. So what's 14 divided by 1.92? 7.2 what? 7.29? And hopefully that makes sense because they're in between the 22 inches and the 6 inches. Yeah? Yeah? Okay, now do we get to go to 5? Okay, number 5. Astronomical measurements are often made by computing the small angle formed by the extremities of a distant object and using the estimating technique in 15.5.1. What is that estimating technique? In the picture below, the full moon is shown to form an angle of 1/2 a degree when the distance indicated is 248,000 miles. Estimate the diameter of the moon. So I think what they're doing is they're just going to say that even though it technically would be an arc right here, since it's so far away that's essentially a straight line. So we just have to find the length of that arc and we can approximate that as the diameter of the moon. Yeah. So we're going to go right-handed here. S equals R times theta. So the radius this time is 248,000 miles. Okay. The angle, however, is not 1/2 a degree because the angle has to be in radians. So I'm going to change that into radians by going 0.5 times pi divided by 180. Okay, so that angle in radians is 0.0087. If I take that and multiply it by 248,000. And our estimate of the diameter of the moon is about 203,164 miles. You guys want that or you want me to do it? You did? You got what? How'd you do it? I have to double click. You know how much time that takes to click on the icon twice? Okay, so is that the only thing for number 5? Alright, last one then, number 6. An aircraft is flying at the speed of 500 miles per hour at an elevation of 10 miles above the Earth, beginning at the North Pole and heading south along the Greenwich Meridian. A spy satellite is orbiting the Earth at an elevation of 4,800 miles above the Earth in a circular orbit in the same plane as the Greenwich Meridian. Miraculously, The plane and satellite always lie on the same radial line. In other words, they're right above each other the whole time. So the spy satellite is hiding behind the plane. As it goes along. Okay. Miraculous, assume the radius of the Earth is 3,960 miles. So you get the picture right here? And this is definitely not drawn to scale because this is 500 miles and that's 4,800 miles. So right? Yeah, close. 96 times as far above. Really above. Okay, when is the plane directly over a location with the latitude of 74 degrees, 30 minutes, 18 seconds north for the first time? This looks like fun, huh? Oh yeah. Alright, so this is 90, yes? Okay, so the plane is flying this direction. Latitude 74 degrees, 30 minutes, 18 seconds means that this angle right here is 74 degrees, 30 minutes, 18 seconds. Okay? Unfortunately, we need to find out what this angle is so that we can use that to find the length of that arc, and then we can translate that into a time because we know the airplane speed. So if we have 90 minus that, and we're going to keep 90 degrees. I wonder if this is going to work. Minus 74 degrees. How many minutes? 30 minutes. I'll show you a second. Where's the second thing?
It's above it's on the plus.
Okay. Alright, so that means, yeah, that is right.
I think I found mine.
You got what? Did you not put a 90 degrees? No, yours is right. 93, but mine is wrong. You got what? Okay, you got what? 15.4. So that angle equals 15.495 degrees. And the fact that it's degrees is important in vectoring. The way we would do this one in the second city is we didn't have that little piece and then the calculator would do go 90 degrees minus, I guess that's 50.2 or something, 74 plus 30 divided by 60, which you probably could figure out that degrees, okay, plus 18 divided by 96. And if you do that, then you get, because it's seconds all the way to degrees. 15.495, is that what you told me? Yeah, 15. Okay. Caleb? No, we're not even done with radius. Okay, so we have to change that into radians. Because the arc length formula always uses radians. So in order to do that, I have to multiply by R180. Divided by 180. So that tells me the degree, or the angle in radians is 0.27. You're not going to get different answers again because I'm going to use the exact one. Okay, so to figure out that arc length, I have to go the radius, which is how far is the plane above the Earth? The plane, this is the airplane, is 500 miles. Oh, okay, 10 miles above the Earth. But we need to know the radius of the entire circle. So the radius of the Earth itself is 3,960 miles. So what do I use for R? 3,970. So I need to go 3,970 times 0.37. So that tells you the arc length is about 1,073 miles. Alright, so we want to know when does it get to that location for the first time? How fast is the airplane traveling? 500 miles an hour, so how do I figure out how long it will take to travel? And divide that by 500. 2.15. 2.15 hours. satellite mean? So how long does it take the satellite to get over that same location? How long does it take the satellite to get over that same location? If they're right on top of each other, right? Same amount, 2.15 hours. And how far will the satellite go? Well, the fun thing about these angles is the angle the satellite will travel will be the same. So we can use the same angle that we did for the airplane to figure out the arc length of the satellite. Is that what we did? Okay. So the distance that the satellite travels is equal to the radius of its circle, which is 4,800 miles above the Earth plus another 3,960 of the radius itself. 3,760? Oh, let's check that. So the radius is 8,760 miles times the angle is 0.27. 0.27 what? Alright. Accuracy is exciting. So 8,760 times 0.2704 means that in that time the satellite will have traveled 2,368 miles. Okay. So how do we figure out its speed? Divide by the time it took to travel that far. How long did it take to travel that far? 2.15. So 226. So the speed was a distance divided by the time. What is it? 1,103. I'm glad that you said that, because I had someone in the class last year, I can't remember who it was, but after we did the problem, they came up to me and they said that they figured out using the physics equation, and if the satellite was going that slow, it would fall out. But it's not. Okay, C, when is the plane directly over the equator and how far has it traveled? So what is the angle then? 90 degrees. So we know, so we know the angle in radians is 90 degrees is what? Pi over 2. So pi over 2 times the radius of the airplane travel, 3,970. Anybody got that for me? 6,236 miles. Okay, so that's how far it will travel when it gets all the way to the equator. Hope it's not a full tank of gas. How long will it take to get there? Divide by how fast is the plane going? 500 miles an hour. So divide by 500. 4.463. Okay, how far has the satellite traveled when the plane is directly over the equator? Well, we know the speed of the satellite now, right? And we know it's going to take the same time for it to get there.